Hello everyone. This time I'm going to teach you how to divide radicals with different indices. Let's have a quick review first on how to divide radicals with the same indices. So if the radicals all have the same indices, all we need to do is to perform the division on the coefficients and also on the radicands. So here, 4 over 16, we can simplify that as 1 over 4. 51 over 17, that's 3, I think. So that's cube root of 3 over 1, right? So the answer here is going to be equal to the cube root of 3 over 4. So that's how we divide radicals with the same indices. If the indices are different, just like in here, square root of 2 over the fourth root of 6, we need to do something to make the indices the same. And how are we going to do that? First, I'm going to list here, right here rather, the indices 2 and 4. And then I need to find the least common multiple of those two numbers. Multiples of 2 are 2, 4, and then 6. Multiples of 4 are 8, 12, and 16. And here we can clearly see that the LCM, or the least common multiple, is 4. So that means in the denominator we will keep that because the index is already 4. But in the numerator we need to multiply both the index by 2, so that it will be equal to 4, and also the exponent of 2, which is 1, we need to multiply that by 2. So now that will be equal to the fourth root of 2 raised to 2 is equal to 4 to the fourth root of 6. Now since the indices are now the same, we can simplify 4 over 6, and that's just the same as the fourth root of 2 over the fourth root of positive 3. Now, since we do not want a radical in the denominator, we will rationalize this. So, to do that, I will multiply this by fourth root of 3 raised to 3 because I want the radicand 3 to have an exponent of 4, so we can simplify it because the index is 4. So, I will also multiply the numerator by that, and this will be equal to the fourth root of 2 times 27. 3 raised to 3 is 27. This will be the fourth root of 3 raised to 4. So our answer here will be the fourth root of 54. And I can now cancel that fourth root of 3 raised to 4. That is just equal to positive 3. Let me give you another example. Okay, so here, first step, look at the indices. They are 5 and 2. And then you need to find the least common multiple. Multiples of 5 are 5, 10, and 15. Multiples of 2 are 2, 4, 6, 8, and then 10. So I can stop there. That's our LCM, which means I need to multiply the denominator, sorry, the index rather, that 5 by 2 to make it equal to 10. I will also multiply that 8, the exponent of 8 by, there's a 1 there, right? By positive 2. Also that x squared, I will multiply that by 2. In the denominator, the index is 2, so I will multiply that by 5 to make it equal to 10. 2 raised to 1 times 5. Then x raised to 3 times 5. Okay? So this will be equal to the 10th root of 8 squared, which is equal to 64. Then x raised to 4 all over 3 times the 10th root of 2 raised to 5. Okay, or that is equal to, what's 2 raised to 5, by the way? That's equal to 32, I think. Right? 2 raised to 5 is equal to 32. So x raised to 15. Okay. So now we can clearly see that the indices are the same. So therefore, we can now perform the operation on the coefficients and also on the radicands. So this is the 10th root of 64 divided by 32, that is equal to 2. So 10th root of 2 over x raised to 4 over x raised to 15, that's 4 minus 15, but we want to make the exponent positive. So it's going to be 15 minus 4, and that 11 will be in the denominator, the exponent 11. So 3 tenth root of x raised to 11. All right. Next. All right. So maybe you're thinking, oh, we can simplify x raised to 11. You are correct, because that's x raised to 10 times x raised to 1. But if we do that, we will make the work here longer, because there will still be a square root or 10th root of x in the denominator. So what we want to do is to really get rid or remove the radical in the denominator. And to do that, I will again rationalize this one by multiplying both the numerator and the denominator by the 10th root of x raised to 9. Why 9? Because we want to make sure that the exponent is a multiple of 10 or divisible by 10. So we can simplify it. So 10th root of x raised to 9. So the answer here is going to be the 10th root of 2x raised to 9 over 3 the 10th root of x raised to 20. And now we can simplify the denominator. So to do that, we just need to divide 20 and 10. That's positive 2. So this is 3x squared without the radical sign. All right. Let's go to the last example. Okay, so we have here 6 and 9 as our indices. We need to find the least common multiple of 6 and 9. 6, 12, 18, 9, 18. I think we can stop there. There you go. That's our LCM. So I will multiply that 6 by what number to make it equal to 18? That's right, it's 3. Also the 5, I will multiply that by 3. And of course the 4, I will multiply that by 3. And negative 8. 9 times what equals 18? So 2, right? So 9 times 2. And x raised to 3 times 2. And then y raised to 7 times 2. And this will be equal to 12 to the 18th root of x raised to 15, y raised to 12, all over negative 8 to the 18th root of x raised to 6, y raised to 14. Right? Okay. So now we can perform the indicated operation, the division here among the coefficients and the radicands. 12 over negative 8 is equal to, both are divisible by 4. In fact, that's the GCF, so that will just be 3 over negative 2. Next, among the radicands, so 15 over x raised to 15 over x raised to 6, we will subtract the exponent, 15 and 6, that's equal to 9. So 18th root of x raised to 9. And then with y's, 14 minus 12, and that goes in the denominator, the answer, y raised to positive 2. Okay. And again, we have here a situation wherein we need to rationalize this. So to rationalize this, I will multiply this by the 18th root of y raised to, guess what? Okay, that is correct. It's 16. Again, why? Because we want the exponent to be either equal to 18, the index, or an index or an exponent rather that is a multiple of the index. So we can simplify it. So I will multiply also this numerator by y raised to 16. And the final answer is going to be 3 to the 18th root of x raised to 9, y raised to 16. Okay. So 2 plus 16 is 18. And the 18th root of y raised to 18 is equal to just y. So this will just be equal to negative 2y. And that will be the answer for this one. And that's how we divide radicals with different indices.